Hello, everybody. Welcome to another fantastic episode of Digital Transitions Project Lemonade. We are going to give everybody a minute, I think, just to let people trickle in before we get rolling on the presentation, introductions, and things like that. So hang tight. Kate and Arnab are in the chat. If anybody needs to ask any questions, they'll be moderating, all that good stuff. So we will just hang out here. Wow, we have lots of people from all over the place. Very fantastic. Baltimore, Poland, Las Vegas. I love it. Perfect. All right. It's been a minute. Great. So anyways, like I said, welcome to Project Lemonade. I am Spencer Zitterich. I work in tech support and R&D at Digital Transitions. And for those of you who don't know us, at Digital Transitions Cultural Heritage, we design and manufacture imaging solutions, provide education and trainings, and offer digitization services to the museum, library, and archive community. Today, we are thrilled to have Don Williams of Image Science Associates sharing information about the updated FADGI 19264 targets and the updated GoldenThread software. So to introduce Don, Don Williams is the founder of Image Science Associates. His early 25-year career before the epiphany with the cultural heritage sector was spent as a research imaging scientist at Eastman Kodak, where he was exposed to a broad categories of digital and analog imaging modalities. Since then, he has worked with the world's largest libraries to help create and modify the FADGI still imaging guidelines and supporting reference targets and software to support that effort. So without further ado, I give you Don Williams.
Good day, all. I won't say morning, afternoon, but I suspect it's evening in some locations. So this is the opening slide. It's meant to, it's a bit of a tease, and you'll see a portion of the first part of what we'll be speaking about, and that is a new target that is intended to be pretty universal in a way. We can measure a number of different performance metrics for digital imaging. When I first showed this to somebody, they were looking for the dancing troupe to come out. So this is just a static image for now, and this is we'll just start with this and give you some background on what FADGI is, what 19264 is also. So into the next slide. This is what you'll be seeing. I'll give you some background about FADGI. That's how I pronounce it. Some pronounce that with a guttural G. And then there's the ISO 19264. I'll explain what that is. So it's just a number, and it's under the ISO, International Standards Organization umbrella. And the ISO has a number of different levels. There's an actual standard, there's technical documents, things like that. Most of the first half of this will cover the updated 19264 compliant target. I notice how fast I say that. I've been doing this a while. We'll do a comparison to other targets and what those new target features are. We're pretty proud of it. It took some while to actually come to agreement on this and what it would be doing. And then following that is, well, you have a target, what do you do with it? You collect data from it, and then you say, okay, well, we want to analyze that data in terms of digital imaging performance. So we have also had to upgrade our software to measure the new metrics and to put a bit of razzle dazzle on to make the software easier to use. We've learned quite a bit over the last 7 years on how to make it easier to use for the end user. Just briefly, there's some integrated and color-coded star levels, not only RGB, but also colorimetric reports, and what I call profile-ready color data exports. We don't do color profiles, but we've worked with the manufacturers of color profile software to ask, okay, so if you have a license for this particular software set, and how would you like us to export the data that you can build that profile from? So we're really trying to enable color profiling in an easier fashion rather than have two targets and go through a couple of different apps to finally get that color profile. And if it's a word, I coined it oodles more. Okay, what is FADGI? I'm not going to spend too much time on this. Most of you know it. There's the bold letters in what it means. It's an initiative on guidelines for digital imaging. It's a collaborative effort of the federal agencies to basically enable sustainable practices for digital imaging, specifically with objective performance metrics. The objective, so two items to remember there. These are all ISO vetted metrics, and they're objectives. So they're not, we're going to look at an image and make an evaluation. No, these are actually objective metrics. And it's for both digitized and born historical content. There's two groups, the still image and the audio-visual sides. We're just going to concentrate on the still image because that's what I know, and I don't know a thing about the audio-visual side. Okay, I guess I click backwards. Okay, what is 19264? There's typically a little bit of confusion around this, so I'll try to declutter that. Initially, back in the oldie days, there were two guideline initiatives around cultural heritage for digitizing content, objective metrics. They both use the same type of metrics, all ISO based, but they were different. But largely, they were different but similar. And some would say, oh, it's a distinction without a difference. Yeah, okay. It's a nice catchphrase, but the observation was, well, can't we collaborate on this and come up with a common set of metrics and what they're supposed to do? So that's what standards organizations are meant to do, is to bring agreement on how to do things. And that's what 19264 is. Now FADGI typically is based in the US and largely managed in Washington. And then there's the other one, Metamorphosa, and that's out of the Netherlands. So those two are meant to come together under ISO 19264. So they're channeled through that common hub. It evaluates image quality characteristics from a single image. So we're really trying to make this easy so you don't have to have 5 different targets to measure the performance. One target pretty much does it all. We're not always going to get all of them, but I'm going to cover 95% of them. And it states which characteristics are measured, how they're measured, and how the data is presented. It applies to scanners and digital cameras for digitization of cultural heritage material. Okay, so that's the background. So let's get to, well, hurry, Don, what is this new target? Well, here's the old, I won't call it old, here's the current FADGI target and the new one that is being suggested under the FADGI umbrella. The one on the left, many of you probably recognize it and perhaps are already using it, and that's what we call, that's the device level target. That's its common name. Sometimes it's called the DICE target. But it was actually a really good start, but we learned over the last several years that, well, we could make it better. How do we do that? It was a good start. We will continue to support it. It'll continue to be used, but for certain applications and institutes' criterias, they may want something a little bit more comprehensive. So that's the 12 years of experience and standardization on the right. That's the full image that we've opened the curtain, and there on the right is the entire target that we're thinking about. It's a little bit bigger, and I'll tell you what those features are, and that's what we're going to be going through here quickly. Okay, these are the mechanics of it. It's A4 size. For you pizza hounds, it's thin crust. It's 1 millimeter tempered steel plate. It is flat, so unless you drop it, unless you start bending it, it's going to stay flat. You'll see in the lower left-hand corner, there's a QR code in an OCR serial number. It'll have machine vision detection features. So what we'd really like to do is just say, okay, click and drag this somewhere, and we'll handle it from there. No click and drag. It's just, here's the image, go do it. It has both metric and inch horizontal, vertical, dimensional scales. It has a veneer over it. It's a Canson semi-gloss paper on top, but underneath is, as they say, that's where the engine is at, is the features underneath it, with subsurface color inserts and flush-mounted SFR features. Those, for those of you who aren't familiar, the SFR features are those slanted edges in the corners and in the middle. We've made those a little bit more concise from the previous target. We had to make room for other real estate. We're confident that'll be sufficient. Okay. If I could only see, just a minute. There we go, I see. These are the colors. Let's concentrate on the colors. There's 168 of them. They're all unique. They're suitable for creating ICC color profiles. So you've got 168 patches here, and there's a mix of them. There's the Munsell colors. Those are 16 gloss grayscale patches for measuring tone scale, spectrally neutral, as well as legacy colors, the 18 matte ColorChecker Classic colors, and those are down in the lower center. You'll see those. Some of you may recognize it. They're just the chromatic colors. The larger population of colors are from the natural color system. They're semi-gloss, and with an aim towards the cultural heritage community, we've populated them with typical parchment and vellum paper color content. So for those of you who are familiar with the LAB system, most of those colors are in the positive A star and B star region of the LAB space. We'll see that here in a moment. Again, those are QR coded and serialized targets. Everyone is measured. With the target comes its own customized measurement, both spectrals and LABs. And, you know, everybody's special. So sometimes you say, well, maybe people have their own colors that they're very interested in. So if you'd like, we can always customize with user-selected colors with upgrades. So for instance, gold leaf, not real gold, and some fluorescent color. I'm sure the listeners have other ideas of the types of colors or features, content they would like in there. So that's how we've adapted it. We've taken a cue from the IT8 targets, where along the right-hand side of the IT8 targets, the ISO allowed manufacturer-related colors, so ones that they thought were important for them. We do the same for you. So how does that target in terms of colors compare to the other ones we're familiar with? So that's what this is meant. This is a two-dimensional A star, B star with, as well as we can do the colors rendered according to the measurements we made with the targets. Something in the upper left-hand corner, there's the ColorChecker SG. You'll see it's there's some high gamut colors. Each of these have their own nuances. You'll see in the positive A star, B star, upper right-hand quadrant, that there's those classic flesh tone concentrations, and that's there. I think there's about 14 flesh tones that they inserted in there, based on portraiture photography. So let's go to the next one, over to the right-hand side, upper right. There's the next generation target, version 2. You'll see that it's not the same as the ColorChecker SG, but it has its own custom colors. In particular, notice that one quadrant of the A star, B star diagram where it's much more concentrated with respect to vellums. And then there's the one we'll be describing here today. We have some, not quite the same as the ColorChecker SG. We have some that are higher gamut, some are less. The one thing we couldn't do, frankly, is the ColorChecker SG in that lower right-hand quadrant. They had some very, very high gamut purples and blues that we couldn't match with our custom setup. But we concentrated on cultural heritage type items. So that gives you a sense of the context of the different colors of each of these targets. One item that we worked hard on and that was required under the 19264 statutes or criteria was an equal L-star set of patches. And that's what we've outlined here. So these are spectrally neutral, and they go in 5 L-star increments from 90 to 20. Okay, no big deal. We can do that. But what we've really done is we've done a linear L-star gradient. Think of that. No, really, this is linear L-star gradient. Okay, just a minute. I think. There we go. I'm back. And as soon as I expand my screen, sorry for the interruption, folks. There are, let's go back. I don't know how that happened. Here we go. I'll continue. So equal distances going from left to right are equal differences in L-star. You can go a difference of 1 millimeter, and it'll be an equal difference in L-star from beginning to end. And we've verified this several times. It has tick locators at the end of each of ones, and we'll show some examples in the software side of how this can be useful. One of the ways is you can check for L-star smoothness criteria, that you're more confident of what's happening between each of those L-star patches. Finally, nothing new here. This is the resolution. Still have the 5 SFR features, horizontal and vertical. And we've added a central focusing aid here with not only concentric circles, but high granularity items that will tend to tease out the artifacts with bare pattern arrays. And some added features is we can measure lighting uniformity very well. That we mentioned that top piece is a Canson inkjet veneer, and the advantage to that is doing this with inkjet, you can get very, very uniform coatings over that entire region of interest. We couldn't do that with photographic techniques because of it just wasn't that possible with processors. We can measure full geometric distortion. If you see all those black dots across that field of view there, that's where we measure distortion. Not only at the edges, typically called TV distortion, but everything in between. We can see if things are rotated, whether they're skew, and we'll show you how we can display that in the software. In addition to that, we can also measure if the lateral color error based on how those color centers shift between each of those dots. So that's another way we can measure color aberration. And finally, we have white, gray, and black vertical and horizontal bars. Those are very useful for measuring streaking, banding, those types of artifacts in the image. I don't know why that keeps coming up. Okay. And so that is a sense of the target itself. So how do we now measure this? How do we use the data that comes out of that? And so let's go to the next one. So this, okay, I'll take a break here. Where we're going next is how do we analyze that in the software? Some of you are familiar with the GoldenThread software, and that software was a good start on the device level target. But now what we're going to start is seeing how do we get this new target involved with that, and how do we make it easier to use? So this is the opening panel of the GoldenThread software. Some changes we've made, especially under that big number 2 icon in the center, is we've really gone a little bit backward and said, well, wait a minute. We found that users are doing a lot of mouse, click type stuff. And it's basically, it's a pain. So we said, okay, FADGI has all these different project types, and all those items are described with tolerances and aims. So he said, okay, let's just have the user select that. And what about all those other parameters that came up in the old software where you had to say, okay, what color space, what DPI, what star level? Well, what we've done is you'll see we've included all those in one packet. So you'll see in the upper right-hand corner here that we have all the 4 standardized color spaces that you can toggle between depending on your use case. If you come in with an embedded color profile, it will also handle those, even if they're custom. So we will honor all of those standardized ones plus anything that comes in as embedded or as a sidecar color profile. We also have, we're going to be going over some setting panels here soon to show you how what's under the hood that you may not be aware of. Okay, so here's the settings area. I wanted to concentrate on this because this is where we've, I wouldn't say hidden, but this is where we put a lot of the items that were a little confusing. So for instance, with our smart search option, in order to avoid blemishes, dust and dirt on any of the patches, we now search, allow the user to set the criteria for searching within a patch to get the areas of low blemish, low noise, and to basically give you the benefit of the doubt to help reduce the variability in the measurements. By the way, you can set these number of searches up to 25 if you want within a single patch. So if we have 168 patches and you're doing that number of searches within a patch, it may take a little time. So just be cautious on how you use that. We're enabling QR code detection. Some of these are typical, but what we're now starting to do with all the object level targets is they are all serialized and they are all measured. So when you read in an object level target, it will detect the serial number in it and in turn look that up in the database of the color reference for that specific target. So we are no longer, we're really trying to get away from batch statistics for color data. We found we're just getting too much variability. And frankly, phone calls to me. I said, okay, how do I minimize the phone calls? Oh, most of them were because the target colors varied slightly between each of them. So we measure all of those now. We also, as you'll see, we display all the star levels at once and show you how things change between them. You'll see that you can color code those depending on how you would like them. You can, if you want the 4-star level to be chartreuse, you can do that. It's all up to you. I'll give you an indication of that. And finally, under the settings, you can, for color, you can describe what default color profile you'd like to use if nothing comes in as an embedded profile. And we also allow you to do what rendering intent you'd like if you're switching between any. So that's the basics of the settings. And then we go on, here's how the regions of interest are placed all in total once the target is analyzed. You'll see vertical, horizontal gray bars at the top. And yes, you will see a number of those patches. That's the smart search option placed on there. Those are no longer in a nice row, each of those regions of interest for the color patches. We are searching within each patch to find the area of low noise, low blemish, low scratches. That has worked out really well for us to get more consistent and less variable data. What else can we'll go over specific ones of these. You've noticed that you can toggle these depending on which ones you're more interested in. We're showing all groups right now, but if you're interested, you can also say, just show me the SFRs. Just show me the grayscales. And that's what we're now allowed you to do. Up here, this is consistent with the current software where it's telling you what color space we are analyzing this in. This is how the data is coming in. Here's some examples of how those star levels are now color coded to show you where things are in spec and where things are out of spec. Here, let's start with the one in the upper left. What we're looking at there is what's the difference from aim, from where it should be, that's the 0 bar horizontal bar, for the target that we read in under the Adobe RGB 98 profile. And so it's basically, it's saying, well, you did really good on the darks. That's the green area. That's the 4-star area. And then the blue, yellow, orange, those are the regions for the 4, 3, 2-star. So all in one view, you can see where you lie. If you go all the way to the bottom of that graph, you'll see it says, oh, what's the independent variable? I would like to see how that relates in the L-star world. If more of you are familiar with the density world, you can toggle that and you'll get a different view. And so these are some of the more, I'll call them user selectable options that are now available to you to make it a little bit easier to use. And you'll see that just for demonstration purposes, I switched from Adobe RGB to Pro Photo. So this one down here says, if you wanted to look at that in Pro Photo space, what would it be? And so this is how we're switching back and forth between the different standardized profiles. You don't have to hit them, but it gives you that option to let you know. Again, you'll see right here, we've detected that serial number, and it is using that serial number and the colors associated with that target in this evaluation. Some other nice features. Here's that L-star component. One of the toggles in that first panel is, I want to know what lightness in, lightness out is. And you can see that generally in the green zone, the way we have it indicated, that the black dots are the measurements. And you're saying, oh, generally you're doing very well. Most of the things are in the green, and then they're in the lower green, and then they pop up to the higher green. And by using that L-star gradient, you can see that hitch. It pops up just a bit, just like it shows it pops up here. So this is one way you can use that L-star gradient. These are these ups and downs here. Those are the tick marks to indicate where the start and end of that gradient are. We had to give some reference points of what those were. Finally, here's a graph of how the geometric distortion will be displayed. This is an example we used, and you can set the scale here. It comes up 0 to 5, but we did this with a linear array scanner, and because you can imagine there's very, very little distortion in linear array scan. I think this was done with one of the Epsons. You can say, okay, so everything's relative to the center of the target, and as you go out to the edges, there are some errors in terms of pixels. Now, remember, we've got this scale pegged up to 500. And so at some point we say, well, can you really measure down to 1.8 pixels at 600 dpi? Maybe not. But it gives you some context of where you lie with, especially with cameras, digital cameras that are not linear array scanners, is that the lens will introduce those kinds of geometric distortions. And this gives you a sense of how great or minimal they are. Finally, we do all these measurements, and then can you give us a summary? So what we've done now is done, as someone described to me, oh, it's a linear pie chart. That's pretty much what it is. We say, okay, for white balance, 58% of your metrics were within the 4-star, 19% within the 3-star, et cetera, et cetera. Again, you can switch back and forth. If you're not quite comfortable with colorimetric evaluations, you can go to RGB calculations. Just to let you know, those are not linearly related metrics. Is that they're if you go between RGB and colorimetric, it's not, the formulations there are not ones where you can just scale things. It's not a linear relationship. We are trying to move away from the RGB world. The reason we did that initially was because going to LAB 10 years ago, we would have lost people. Most people were just not familiar with the colorimetric LAB approach, the way humans see it. The RGB approach is how the camera sees it. And the difference between the camera and the human is we have different detectors. Some are more sensitive in different colors than others. And by the way, the camera input color profile offers that translation between the two. And that's what this is. I think this is the last slide. Oh, the new software will support the current device target, all the object level targets. And I have to give a pat on the back to Doug Peterson, because he did say, well, Don, we always have to go in and tell it what size it is. Okay, we're doing away with that. You can measure any of the different size object targets, and we'll be able to detect them, which one it is, largely from the serial number. We will support all the typical, we call them row column matrix color targets, ColorChecker SG, ColorChecker Classic, next generation target, and some of our miniature color gauge series. We'll have film and 4x5 film support also, just like we do in the current software. And I knew that this subject, we're expecting this with most of the bugs worked out by the 3rd quarter of this year. And that's, I see I don't have a forward arrow from here. So let's see what the questions are, or whoever handles that.
Question here is, can you just clarify if GoldenThread can read embedded ICC profiles?
Yes, absolutely. We do that in the current software.
Perfect.
Yes.
Thank you. Okay. Next is, what's your opinion about the X-Rite I1 range of kits for color management? And is it compatible with the Target and GoldenThread software? can both be used in the same workflow. So I think, you know, how are those I1s as hardware, if you find them reliable, and presumably the numbers?
Oh, I do find that, yeah. Actually, the I1 Pros are quite reliable. They're a very good sedan. Yes, they just they work well. They're not, I wouldn't call them laboratory grade, but they are certainly high field grade devices. Absolutely.
Great.
Yeah. And I see now with their new ones, they added another measurement protocol to it, and they also do polarization measurements.
Yeah, I believe the Pro 3 model, I saw that as well. It looks pretty promising. And I think to the second part of that question about being compatible with the target and the software, you can certainly measure any target with the I1 range, but you would use an external software to actually take your measurements. But GoldenThread will, of course, take those colorimetric measurements once you have obtained them.
Yes, we're the way we're going to start doing that. We hadn't in the past is we're just going to accept CGAT files, and that's typically the relied upon format for ingesting that color data, both LAB and spectrally.
Perfect. Okay. Thanks, Don. All right, next question is ISA or anyone else working on creating a target that works with sheet fed or roll-through scanners?
Yes, that's actually available. Yes, and I don't know if the attendees in this particular session are quite aware of that, but the NARA put out an act for the 2020 timeframe, 2022 timeframe, where they're no longer accepting hard copy records as of that date. So there's a big effort to digitize all federal records, and they're doing it with sheet-fed scanners. We were quite surprised. People are meeting FADGI 3-star levels at 300 and 400 DPI with sheet-fed scanners at 30 pages a minute. We were a little surprised. I know I was. So, yeah. So we do. Oh, yeah. We have flexible targets, actually.
All right. Thank you. All right.
This is Arnab here. I just want to chime in real quick. If you could go and sort the questions by oldest first rather than newest, maybe we can answer the folks that asked questions first.
Got it. Sure thing. All right then. So
first in, last out. Okay, sorry about that, guys.
So your first one might be a doozy. It's from Dave, and it is you just.
Dave who? Wait a minute.
I think we know which Dave. He's asking if you could clarify how FADGI or ISO 19264 is applying to born digital content, if at all.
I'm going to be honest with you. You're right. It is not clear, and that's because I don't even think it's on the radar of born digital. Yeah. You're good. Really good question, and I don't. That's not being attended to.
All right. Thank you. Okay. What does NXT mean as in regards to the GoldenThread software?
But that's a good question. It was. I don't know. It was as they say, it was an internal specification. Let's see. I think the X means experimental. N means the new experimental target. And now that name may change, but maybe it'll stay that way now that we've introduced it.
All right. There you have it.
You know, okay. Well, for the people who were born after 1980, there's the Polaroid SX70. SX meant for special experiment.
There you go.
Okay, just a bit of trivia. Yes, you can share that at your online cocktail
Awesome.
parties. Yes.
All right. Let's see.
Well, it was photographic related. Okay.
All right. Will there be an ICC creating module within the updated?
Well, here's the issue. There's two approaches to that. Right now, we're concentrating on 3 different engines, color profiling engines. One of them most people are familiar with is Argyle. Now that's free, and we can actually create profiles from the Argyle software right within GoldenThread. Now, I'm not going to say which color profiling engine is better. Sometimes it's free is better, but I know a big portion of people use more commercially based ones, Basic Color, and forgive me, Larry Spivak, but I've SpectraCore. Larry Spivak has just come licensed software from X-Rite, color profiling software from X-Rite. Now, those all require licenses. So what we are going, this is what I meant in my initial slide when we say we're going to give you color profile ready data so that you can export that data and read it directly, ingest it directly into those 2 commercial engines, depending on whichever. But we're not going to handle the licensing for that. We're going to say, okay, if we might be able to call those engines if you have a license, but we're not going to. No, we're not going to step into licensing issues, except if it's free, like Argyle. And yeah. So I hope that answers.
I think so. Okay, so the Munsell grayscale target goes to L star 5 at the lower limit there. Why does this target stop at 20? Can you speak to that?
Yes, I can. Well, one is because the 19264 spec only requires it to go to 20, I believe. We can start going to those lower levels. It is very, very difficult to maintain consistency at those levels. When you start getting down to L star 5s, now you're getting within, you get very high margin of error with classic measurement instruments like the i1 Pro. You'll put down that i1 Pro at what is considered a nominal L star 5, and you take 4 different measurements, and it'll be L star 5, L star 3, L star 4, L star 6. So it'll jump all around. So it's really a reliability and consistency issue when we get to those very, very dark patches. We just can't reliably reproduce those kinds of items with inkjet. Yeah. So though all those L star scales, by the way, are inkjet. Just to let you know, they're very, very fine inkjet, and we do not measure noise with those. But as it turns out, with our measurements, we find that those grayscales, those L star grayscales, are actually more spectrally neutral than the Munsell patches. That the Munsell patches do a deep dive once you get to the 400 nanometer area, and those inkjet ones, they stay afloat.
Fantastic. And I think I kind of just want to add just one quick question onto that, which is you mentioned the inkjet. Could you clarify, is it just the inkjet substrate on the top, or did you mention if there's a coating on the top or a film over it?
No, it's just on the, yeah, it's just on the top, right? And then we laser out windows where we put the colors and the SFR
Perfect.
features. Right.
Thank you. Okay, so our next question is, can GoldenThread be upgraded to work with the new target? And I think you answered that already, in that it will be supported in the new
Yes.
version, the NXT for now
Yes.
version, but not the
For
current
now.
iteration of GoldenThread, right?
Or maybe we'll have a naming contest.
We can do that for our next poll.
Yes, being a smart. Sorry.
Okay, so alrighty here.
Oh, wait a minute. You know, shameless self-promotion. For every purchase of the new target, you'll get an I See Dead Pixels shirt.
That's awesome.
Okay. Okay.
Oh, I love it.
I hear that I have a reputation out there. I don't know.
I'll be looking forward. I'll be looking forward to getting mine in the mail. All right. How do the
Yes. Okay.
how do the color profiles interact with grayscale only images like microfilm? I think that maybe just in regards to white
Yeah.
balance, we don't measure color on
Yeah,
grayscale,
you're right. We really
grayscale images like microfilm.
Yes, you are right. Thanks for answering that. No,
Yeah, yeah.
I appreciate it. Yeah, we do measure white balance with the microfilm targets and the standard film targets. And well, we've been a little bit negligent on that. We do the transmission measurements of those, and yeah, we need to do a little bit better job on getting that data into the film target side of the software.
Yeah, but for now, you know, the best way we can
Yeah.
do it is, you know, to really to measure to validate your color
Yeah.
profile
Mhm.
is that combination of, you know, the spectral
Right.
properties of your light source plus, you know, the white balance of that target with your color profile applied to it. And,
Yeah.
Okay, so moving on down the list. Does the 19264 target, I presume that's what they're talking about, does the target for transmissive work, okay, does the target for transmissive look similar to this new target? Are you updating the old one at all?
We're not the transmissive ones. No. That is that. Yeah, that's a bridge too far for me. Yeah, that's.
Okay. Yeah. That would be quite the undertaking there. All right. Let's see. Moving on the list. So we already spoke to this. The projected availability date for the new target and software, right here up on the screen. Q3 for both of them.
Yeah. Yeah, we're a little bit further with the target than we are with the software, as you can imagine. Right. And I will admit that, like any development issue, the biggest impediment into improving the software is to get scans of the target that we could test with. I don't have all the same equipment as the audience members do. And so, you know, I usually have very, very good framed images, etc. And I've learned over the years that, oh, I see. I see you have the target somewhat skewed and not quite on a flat surface. So it's always interesting to try to get user behavior models out there.
All right. So is GoldenThread software compatible with both PC and Mac? Now I know the current version is PC based, but we run it at DT. Many of us run Mac, so we run it on Parallels, where it works fairly stably if your machine can sort of handle running both of those at the same time. But will the new software be PC only as well, or be Mac related?
Yes, it will not be Mac native. No. I'm sorry to say.
That's all right.
And by the way, it's not like I haven't scolded the developers over that. They said, nope, we cannot do that with the current environment we're in. I said,
Okay, good to know.
But okay, I know I shouldn't say it because most people are under institutional constraints on things like Parallels, but I am overjoyed with how well Parallels works. It is just seamless.
That is my that's my experience as well.
Yeah.
That's my answer to everybody's question of how to run it on a Mac. Parallels. Yeah. So let's see. Okay, we got the old questions already. So now we're back to some new ones that have popped up. Can you speak to pricing at all?
Okay. Yeah. Targets are likely to be in the 1,400 to 1,600 range. Somewhere in there, not quite certain yet. And you're probably asking about the software too. That's a little bit more complex because if you already have a GoldenThread, the old GoldenThread software, it'll be an upgrade. And we haven't addressed that yet. And how we would bundle that with the new target. So I know that sounds like I'm avoiding the question, but I'll just be honest with you. We haven't thought about that well yet. Specifically anticipating the kinds of combinatorial target software options users will want.
No, that's a fair answer, I think. So, and I'm also sure that we'll just let everybody know as soon as we have that info. It'll all be out there.
Yeah.
So moving on down. Okay, how and with what instruments are you measuring the target to create the reference file for your target? Maybe that's specifically for you. Why don't we do that? What instrument are you using?
We use an i1 Pro 2 that we get calibrated every year at X-Rite, right? And we have several of these, and they are between instruments for the same material. They are very stable. We're very happy with them.
Great. Okay, so we have a question about rendering intent. Why did you choose colorimetric over perceptual? Some believe that perceptual is an improved and more subtle gradient approach to rendering color, especially for skin tone.
I don't have a good answer for that. My go-to answer is, since we're always, I claim, interested more in the archiving as an input referred tool as opposed to how things will look on a monitor. So we tend to be input referred as opposed to output referred. And I do understand that for output referred, the perceptual might be a better choice. But our model, my model is we're looking to understand how well we captured things relative to the input, not how they will look on the screen. I think that might answer the user's question.
That's a great answer. Thank you. Okay, perfect. All right. So will GoldenThread NXT be cloud-based? Will it be a subscription software or a one-off payment, which I think maybe you spoke to, and again, PC or Mac? So cloud-based, yes or no? And is
Well,
there a possibility for a subscription model or always one-time payment?
we have our toe in the water on that. The benefit of the cloud-based, of course, is it will. We don't have that Mac constraint any longer. That's the one benefit of that. By the same token, loading up large images might be a problem if you don't have the sufficient bandwidth. So we have been investigating that for about the past 6 months. And it is a major change in our model. And we're well, okay, we're squirming in our seats a little, but we really like the idea, I have to admit. And it probably would be a subscription model at some point. And how we would handle that with current users of GoldenThread, I haven't thought that through thoroughly, frankly.
Yeah, you know, the existing licenses is probably the more complicated part of that whole thing.
Yeah. So, for instance, a service bureau once mentioned to us when we broached this subject, they said, "Oh, there's no way we're going to load up all those images to the cloud." He said, "It'll clog up our system." I said, "Oh, that's right, because they are an institutional manufacturing mode." But it was interesting, and they did say, well, if we had it resident here, we wouldn't mind taking that data, just the data, not the images itself, and uploading it to the cloud. So they offered us a different model.
Okay.
Mm-hmm.
All right. Can you speak to how the new target can help evaluate the effects of optical brighteners in printed materials?
In printed materials. Okay, let me think of that. Well, one thing you could do is if you had specific materials that you thought had that kind of had OBAs in it, those could just be, this goes back to one of the slides where you say, okay, would you like to replace a couple of these patches in here with your own specific kind of content? So for instance, what we tried initially was one of the items we also offer more towards the conservation community is UV fluorescent materials. And so we, as an indicator of, okay, how much UV light is in your illumination system, or how much actually reaches the camera rather, we were thinking, oh, we could put these UV fluorescent probes as a target feature. And if they glowed red under what you would consider your lighting, then you had a lot of UV in there.
Right.
So that's one way of doing it. Alternately, you could put your own materials that you thought had brighteners in it. Or with the i1 Pros, they have different modalities for what M0, M1, M2 illuminations that will indicate whether or not there are OBAs in that material.
That's a great point. Could modify that target. I like that idea. All right, is it possible to use GoldenThread on raw images, in particular for the computation of SFR on images not interpolated?
Yeah. Oh, that's a good question. People, that has come up several times. And whenever I ask developers about that, even ones who are familiar with it, they said, don't go there. Don't go there. They said, if you're going to do that, they said, make a plugin into Lightroom. They said, so don't do it on your own. Do it as a script or a plugin into existing raw tools, raw development tools. The reason is, as someone suggested to me, they say, well, sometimes people will put color or lens correction profiles in there. You say, well, yeah, we're not going to go down that road. That's a whole library full of lens corrections. So we're saying, okay, the best approach for raw images, frankly, is to build a plugin for existing raw processors.
Perfect. Okay. Good. That's really good to know. Okay, so we had a question about upgrade plans, which we addressed. There will be an upgrade for current users. Let's see. Will there be new object level targets also, or will those remain the same?
We're thinking about that. That has come up. You're not the only person to ask that, whoever you are, Otar, maybe. Okay. No, you're not the only person to ask that. I have to admit that we have been so focused on this current target that we haven't even thought about the object level target. Clearly, we are not going to put 168 colors on an object level target. And that's, so it would have to be a subset. It really would have to be.
Great.
So we haven't, let's see, we haven't written it off, as they say, but it's being considered and it's on the shelf.
All right. Will you be introducing a function to do batch processing of targets in the new version of GoldenThread? For example, running 10 targets at once instead of individually.
We already have that, actually. There's an automatic mode in our software. And that automatic mode will run on both device targets and object level targets. So it will do that. And when the summary appears, so you're all done with 200 targets or 20 or whatever, at the end, what appears is an entire list of all those items, and you just click on any particular target and the summary will come up, and you can save all that data. Actually, the people who are using that are the sheet-fed scanner people. They're running this stuff all the time, and they say, we have 200 scans. Oh, I want to see them all. Okay.
Okay.
What happened to boutique imaging?
Oh, we can do it en masse now.
We can do it in mass. Just put them on the bus and take them there. Second Avenue subway. That's it.
Okay, if I use the new GoldenThread target to build, or the new GoldenThread to build a profile, and then use GoldenThread to evaluate the profile, I am teaching to the test. Ideally, the GoldenThread or equivalent should be independent data. Yes?
I see. Yes, and I see the person's name is Roy. I don't know. There aren't too many Roys out there, but no. This is a really good question, because this has come up with the Tom Rieger at Library of Congress. And I think Peter Burns suggested this also. You say, well, you don't really need to. If you use the ColorChecker SG for instance, as a model of how profiles are currently created, you say, okay, there's only really 96 unique colors in that target. You say, okay, so let's designate in our new target, 100 of those patches that we're going to do the profile on. And then on the other 68 are the ones that we also report the non-teaching to the test portion of it. So you can actually present two sets of data, the teaching to the test data and the, we'll call it, yeah, that's the placebo effect, and then the other set is, okay, this is a completely different set of data that we're going to test for. Now, the strategy for that, we haven't thought out. So, but we're always willing to listen to experts, Roy.
That's great. Yeah, I like that. It's really great. Okay, combination questions before we're at the end. We'll combine both of Martina's, which is, why is the target only A4? And are you planning on making a non-metal version?
As in a flexible version, when you say non-metal? Martina, talk.
I think it's safe to assume that might be maybe a paper-based or something more flexible.
Let's say it's not out of the question. Yeah. Do I sound like a politician? I hope not. I'm pivoting. Is that what they say?
And then to that point, multiple sizes?
You know, that's an interesting point. We could make multiple sizes. The reason we couldn't easily do that with the old version was because it was so expensive to put that top piece on. But we've gotten away from going photographic with that top piece. I mean, there are photographic elements, so all those SFR features were, in the old version, very costly because not too many people know how to make those. Yes, traditional photography is dead.
Okay, so if perhaps if somebody was looking for maybe a 24 by 30 inch target, could that maybe be looked at as a special order?
Oh yeah, no, that is not out of the question. Right, that is not out of the question at all.
That's good to know.
Yeah.
Okay, and I think last question here is there a potential Capture One and GoldenThread sync in the works? Some sort of plugin? Well, that's a good question. I know you just said the first time I had heard of plugins before, I hadn't thought about it.
Well, it's either that or I think, as we've told, one thing I haven't mentioned here is that there is a command line option for GoldenThread. So if you want, you can use a command line to call it. Or we've also got a dongle version. So if people in Belgium are using it, so people in, I forget, we have, I think, 2 customers that are using a dongle version, one in Texas and one in Belgium. And it's worked out very well. So they install the software on as many platforms as they want. And as long as they got the key into the port, the software will check, say, okay, I'll let you run it.
Great. Okay.
People, by the way, okay, I'll shut up after this. People have put these on servers. And there's nothing wrong with putting them on a server. Only one user can access it at a time, but you can always tunnel into the server.
Yeah, that's true. That's really.
I mean, basically, that's the same approach a cloud version would take.
Right. Yeah. Okay. Well, I think we have gotten to all of the questions. That's fantastic. Okay.
Right.
Do you have anything else? Anything else to add, Don?
No, just remember, shameless self-promotion is I see dead pixels. Okay.
All right.
Chiming in here. We're probably a dozen
Oh, yeah.
people that asked if they could just buy the shirt. Can they just buy the shirt?
Oh,
Okay,
absolutely.
excellent. How would
Yes,
they get the shirt, and how would people potentially contact you after this webinar?
Okay. Um, uh, oh gosh, what did I do? Okay, contact me at. Well, most people know my email address. It's Don-Williams. Don-Williams at rochester.rr.com. Alternately, Don at imagescienceassociates.com.
Perfect. And it's there in the chat. Thank you, Arnaud. All right.
Okay.
Well, that's all the time we have for today. So thank you, everybody, for tuning in. It's great to have you. I think this is a really, really fantastic Project Lemonade series we had today. So I think at this point, you all know how to reach us. And you've got Don's contact information. So any questions, shoot them our way, and we'll do what we can to take care of you. So thank you, and have a fantastic rest of your day.
Thank you.
Thanks, everybody.
All right, Spencer and Don, if you guys would like to sign off, I'm actually going to leave the session running for another minute, just for those that wanted to copy the chat for themselves. But thank you again for joining us, Spencer and Don, and everybody else. And I will close the room in just a minute.
Okay.
Okay.
Cool. I see some comments saying I'll be ordering a shirt. That's fantastic.
I'm telling you, when he said that in the chat, they went wild. Everybody wants one.
Love it. I want one.
We'll have to work on that.
Yeah, we'll have to.
All right. And we'll give it another 30 seconds or so, and then we'll close the session. Thanks once again, guys. And if you have any other questions or need anything else, you can, of course, contact us at info@digitaltransitions.com. Once again, that's info@digitaltransitions.com.